I am a tutor in Uplatz, and today I am going to discuss about embedded system engineer skills. What is an embedded system engineer? What do the avionics on a rocket, the automated powertrain of a self-driving car, and the internals of your programmable pressure cooker all have in common? They are all examples of embedded system combination of hardware, software designed to perform specific tasks. An embedded system typically consists of analog sensors for real-time data collection, like temperature, pressure, acceleration, etc. Microcontrollers, microprocessors, and/or actuators for decision-making, automation, and control. Embedded software, coded instructions that can run the whole system without human input. Responsibilities of an embedded system engineer is responsible for design, development, production, testing, and maintenance of embedded system. Oftentimes, this role leans more towards the software development side of the equation, which is why this position is also known as embedded software engineer. Core skill sets of an embedded system engineer includes like the system they manage. The embedded system engineer requires experience with both hardware and software. The core skill sets of an embedded system engineer looks something like this. Programming languages such as C, C++, and assembly language are the most common requirements for this position. LabVIEW is also popular for working with National Instruments data acquisition units. Depending on the job position, familiarity with languages such as Ada, Lua, Rust, Python, BSTN, and Verilog may also be required. Microcontroller, microprocessor ecosystems such as Arduino, Raspberry Pi, Atmel AVR, ESP8266, Node MCU, and PIC10FXX. Memory management, a solid understanding of different types of memory, including RAM, ROM, and flash, and how to develop software where memory is a premium. Circuit design, PCB, signal analysis, debugging, assembly, and testing of integrated circuits and their components, PCB analysis, and design software such as Security and Allegro. CAD design, basic hardware design using CAD software such as AutoCAD or SolidWorks. Measurements, experience using digital multimeters, oscilloscope, DACs, and other equipment to measure, analyze, and troubleshoot electrical systems. IoT devices and frameworks such as Google Cloud Platform, IBM Watson, Azure, and AWS. Data processing and analysis, able to process and analyze data using Excel, Matlab, and Python. Technical writing, a large part of the actual engineering job is technical documentation. Even better if you can write research grants. Even if an embedded system engineer never has to directly touch the hardware of the system, they design intimate knowledge of those hardware systems required to properly design embedded software. Skills of embedded system engineer. Embedded systems have come a long way since they were introduced in the early 1960s. Applications of embedded systems are ever increasing, and the trend is growing in momentum with every year that passes. Embedded system and microelectronics have accentuated the importance of technology in our day-to-day lives. We are surrounded by intelligent systems without even realizing it. Your priced MPS player, this GPS system in your car, your microwave oven, and embedded system lie at the heart of these things and so much more. The time is here as we move towards ubiquitous computing. Almost everything from a toaster to a coffee maker is powered by an embedded system. So if you are an embedded engineer, you ought to rejoice at the thought of the sheer number of opportunities open to you. However, in the world of dynamic technology, this could be a double-edged sword. In order to keep up with the overwhelming pace at which the industry is progressing, you need to make sure to keep up with the evolving technology and keep your short run. These are all the 8 skills that every embedded engineer should have. In-depth knowledge, whether you are an assembly language programmer or design embedded circuits, you must have in-depth knowledge in your vertical. The more knowledgeable you are, the more value you bring and the less dispensable you become. Subject matter experts are invaluable. Well, your knowledge base and your reputation as the person who holds knowledge, you will establish a reputation for yourself, your team, and your company while making yourself indispensable. Be an all-rounder. Companies these days are looking for engineers who understand the hardware and software aspects of any design, even embedded system. You don't have to be able to design the board and write the software, but you should have more than a fleeting knowledge of other while working with one. Network. Whether it is the internet, a colleague, internet industry publications, or focus groups, online forums, learn, ask questions, respond to questions, you answer. Take it all in, be active. Aside from growing knowledge, you will grow your social and professional network is probably the best way to learn something on your own. So don't just use it for social networking and entertainment. Maybe someone has already figured out the problem you are facing with your Raspberry Pi board. So take advantage of all the open source stuff out there. Be a part of an online community or a forum related to your domain and learn exciting new things that will help you improve as an embedded system engineer. Learn internet-based technologies. Sooner or later, Internet of Things and ubiquitous computing is going to take the world by storm. When that happens, the devices around us that are already based on embedded technologies will become smarter and communicate with each other through internet-based communication. Knowing that in and out of embedded C won't surprise them. To stay relevant, you need to learn those internet-based technologies today. Become familiar with the latest process. If you are still working on 8051 or ARM, there is nothing wrong with that. However, if your knowledge about the latest process and MCUs is nil, you are in deep water. To be a good embedded systems engineer, you need to have some knowledge and experience with the latest MCUs. So start tinkering with the latest tech on the market as soon as you can get your hands on them. Perfect your project management skill. You are not only an embedded systems engineer, but also a professional. Most of the time, you will be working to accomplish a specific goal with a group of individuals. You will need to cooperate and coordinate with these people, with your co-workers. And while you may not be the project manager, there may be one assigned to your team. Understanding the process, steps, and approach will only benefit you in the long run. Project management skills will help you deal with the various aspects of corporate life. Troubleshoot. You might be a great engineer with exceptional designing, coding, and assembly skills, but even with your superhero-like skills, you will come across situations when your design does not work. Whether it is a faulty IC or a defective component, the bottom line is the issues need to be resolved. Having good troubleshooting skill will pay off in this space. If you are able to identify, isolate, and fix the issues, you will save your self-time, effort, and possible embarrassment. Troubleshooting is not always for the experts. There is a methodology you can use to help through the process. It will take time and patience, but the efforts of perfecting your troubleshooting skills is definitely worth it. Be creative. Your thoughts are your most valuable asset. What makes a good engineer different from an average engineer? Creativity. To design a functional system that stands out from the rest, you need to imagine it first. Your creativity will help you on your journey to become a good, successful embedded system engineer. Creativity is not necessarily something you have to or don't have. It is something you can learn, a skill you need to practice. Play with your children, cousins, and nieces. Close your eyes and picture yourself as a microscopic carrier delivering protocol messages over the bus. Practice. If you don't use it, you will lose it. Acquiring these skills will help you excel as an embedded system engineer. So avoid pigeonholing yourself. Step outside your comfort zone and learn new things. Study the latest trends and be an expert embedded system engineer. Top embedded system skills, engineer skills include software development, Python, C++, Linux, SPA, and other skills. Embedded system engineer skill matrix at the high demand level, there are 14 skills: software development, Python, C++, Linux, SPA, communication protocols, Matlab, RF, I squared C, PCB, product development, system design, data acquisition, USB at average level, 15 skills. That includes Ethernet, Bluetooth, RTOS, DSP, FPGA, analog device, device, Windows, Java, hardware, firmware, UART, SOC, Wi-Fi custom requirements. At low level demand, we have 20 skills: control system, PC, MCU, ASIC, RS-232, API, LabVIEW, GPS, test scripts, Unix, BSP, IDE, assembly language, circuit boards, PID, emulators, TCP, IP, ORCAD, technical support, JTAG. We'll see in brief all the skills and what are the requirements. Software development is a high-demand skill for a embrace of a system engineer. Software development is the mechanism by which programmers create computer programs. Software development life cycle. SDLC is a framework for developing applications that follow technological needs and consumer requirements. It consists of many stages. The SDLC establishes an international standard that software developers can use to enhance and create their program. It provides a well-defined framework for software developers to pursue in the production, maintenance, and design of premium quality software. The aim of the software development process is to create high-quality software on time and within budget. Here is how software development is used in the embedded system engineer's job. Develop software for evaluation, customer demonstration, and deployment using a software development process. Recommend, plan, and implement quality process plan for a software development project that lacked quality oversight for over a year. Design and verification methods, software development, Tata, SVN, SolidWorks project planning. Participate in the hardware and software development of a single button cell phone. Experience with software development in Windows and Linux. Provide hands-on contribution to extensive software development project and serve as primary lane of communication between company, customer, and stakeholder. Python is a high-demand skill for an embedded system engineer. Python is a widely known programming language. It is an object-oriented and all-purpose coding language that can be used for software development as well as for web development. Here is how Python is used in embedded system engineer's job. Implement a significant portion of the software on flagship systems using C and Python. Experience with Java, C++, Matlab, SQL, Python, and shell scripting via course projects. Implement Python tool for generating detailed configuration reports on distributed scale and scale-out appliances. Develop custom Python applications for secure transmission of patient billing information. Implement an automated regression framework for transport process via socket programming using Python. Utilize Python language under Unix extensively to control interface instruments. C++ is another high-demand skill for software system engineer, embedded system engineer. C++ is a general-purpose programming language that is used to create high-performing applications. It was invented as an extension to the C language. C++ lets the programmer have a high level of domination over memory and system resources. C++ is an object-oriented language that helps you implement real-time issues based on different data functions. Here is how C++ is used in embedded systems engineering jobs. Develop Visual Studio C++-based utilities to communicate via C, USB to provide insights regarding the status of connected devices. Configure, design, and develop C++ project using UML and Rational Rose effective software training for US Army. Work on the support side of an audio-video server system programmed in C++ running on a Linux platform. Implement a user interface in C++ for a Linux embedded system interconnecting different devices to RS-232 protocol. Design and develop embed real-time control system software using C++ coding in VxWorks or RTOS environment. Develop C++ code for upgrades on an innovative Navy vessel DDGX-1000 steering mechanism. Work with colleagues to transplant the UI of Qt5 in C++ onto our embedded system. Integrate software and hardware drivers into an upgrade embed and Windows PC utilizing Visual C++. Design a TCP IP based smart home system managed PC control software using C++. Engineer and implement object-oriented C++ software and shell script in a Linux environment. Work on DC motor controls for optics storage embedded system using microprocessor in C++. Develop code in C++, C, and Java for Linux and Windows. Maintain embedded C and C++ software on master sensing field instrument. Develop and maintain C++ for embedded targets. Develop various interfaces in AD using C++. Develop applications using C++ and Matlab. Develop ABS and traction control algorithms using C++. develop corresponding Windows-based GUI using C++, develop the firmware prototype in C++ that read well sensors and sense data over Wi-Fi to the Arduino Wi-Fi shield. Implement multi-threaded waveform controllers in C++, boost C++ thread libraries. Linux is an high-demand skill for embedded system engineer. Linux is a Unix-like operating system. Just like Windows, Mac OS, and iOS, Linux is an operating system used by millions across the globe. Android itself is powered by the Linux operating system. Linux manages all the hardware resources that are associated with your computer. The software is famous because of the protection it grants from viruses, malware, and crashes. Linux operating system is entirely free and is an open source software, meaning it can be altered by those equipped with knowledge to code. Here is how Linux is used in embedded system engineering jobs. Design and documentation of Crank storyboard software engine interface to DM3730 based embedded Linux system. Perform testing and configuration of IP-based digital video board running embedded Linux. Develop device drivers for embedded Linux application. Customize and port Linux kernel in cross-platform Linux with GNU tool chains and download it to target board. Network and control testing equipment through Linux C programs and Windows VBA scripts. Port serial chip device driver from 2.4 Linux kernel to 2.6 Linux kernel plus bug fixes. Develop firmware in C and with the Debian Linux to control and monitor solar system via Canvas. Develop Linux drivers, support NOR flash, NAND flash, serial port. Enhance the Linux MTD flash driver to support a non-standard 64-bit flash geometry. Control center program, a Java program on a Linux workstation controlling the testbed. Developing C in C for integrated solar system with Debian Linux on ARM9. Engage in modification of embedded Linux kernels to align with specific client needs. A key accomplishment, implement embedded Linux board support packages for different platforms. Develop Windows GUI using LabVIEW to communicate with Linux controller through this TCP/IP. Develop C++ control software to run on an embedded Linux on board. Set up and maintain a custom Debian Linux package repository. Customize and port Linux kernel in cross-platform Linux. Design, develop, and integrate features commonly found in satellite, cable, IP setup boxes, SoC involved in Linux device driver development. Install Linux drivers, configure and script custom boards using ARM architecture and Bluetooth-oriented design. Design and develop a wireless system to replace a legacy product based on Linux and Java. SPI is an high-demand skill serial for the embedded system serial peripheral interface. In this, create interrupt-driven firmware for real-time control of peripherals such as A2D power supplies, I2C, SPI, etc. Introduce distributed processing techniques with multiple processors and interprocessor and interboard communication protocols with I2C, SPI, and UART. Implement bootloader code for smart sensor to interact with other unit via SPI as backbone. Develop ADC drivers based on I2C, SPI, and UART protocol. Implement low-level drivers for ADC, UART, I2C, SPI, multiple drivers, and EEPROM. Develop and implement firmware for the SPI, I2C, PW, and UART interfaces for the C peripheral communications. Involved in development and testing of device drivers for CAN and SPI. Perform CAPL scripting. Design SPI interface for LCD and 4-button keypad. Interface SPI accelerometer data logging to SD card. Communication protocols is another high-demand skill for embedded system engineer. Develop ID versatile event tracing tool for analyzing automobiles communication protocols on a serial CAN bus. Design and implement communication protocol for each subsystem. Adopt STI tools to third-party systems and serial communication protocols RS-232, RS-485. Implement and orchestrate most of the above devices so that they utilize CAN communication protocols. Matlab is an high demand for embedded system engineer. Matlab is a platform for programming that scientists and engineers use to explore and design technologies. The Matlab language is a matrix-based language that allows the most natural appearance of computation mathematics is at the core of Matlab. Here is how Matlab is used in embedded system engineering jobs. Implement the GPS receiver in Matlab for evaluating the algorithm for the purpose of FPGA implementation. Use US06 driving cycle as a test standard model and simulated fuel consumption in Matlab. Apply design digital signal processing techniques to NAR sensor measurements using Matlab. Analyze system performance using Matlab and hardware tools to assist mechanical and electrical group for hardware troubleshooting. Design controllers model in Matlab simulate and perform hardware in-loop simulations. Perform optimization of motor controls via testing and data collection using Matlab sibling. Create binary code of arbitrary multi-tone sine waves with Matlabs and import data with FPGA IO port. RF is in high demand for embedded system engineer. Develop entire digital RF distributed system, including implement automatic gain control of the RF signals used for communications between the access points and the mobile devices. Design and write the Visual Basic software to access the USB RF generator and the RF receiver. Project lead for internal research project involving integration of RF tools into one user interface. Team member of RF engineering team. Select projects include TA MSB 430 to MSB 430 RF communication interface using CC1101 radio code. Program firmware of a distributed network of microcontrollers RF communication. Vault and Smart Trash member of software application development for the RF tracking solution. I2C is another high demand for embedded system engineer. Modify I2C firmware to prevent microcontroller program endless loops. Save for an I2C IP code for temp. Verify system communications using oscilloscope logic analysis and I2C protocols. Develop I2C communication for display data. Develop a driver program to read data into EEPROM ATML 24C16 using I2C bus. Develop an API for the UART and I2C for the XMC 4500 controller. PCB is an high demand for embedded control system engineer. The PCB printed circuit board refers to the hardware part housing of all of the device's electrical connections. Here is how PCB is used in embedded system engineer's job. Design PCB layout in Eagle CAD with consideration of manufacturing of specification. Coordinate PCB fabrication and population with outside vendors. Participate in the hardware, PCB layout, software, and mechanical design for other projects conducted by the company. Bench testing on both PCB circuit signal and software data communication by the using oscilloscope, related meters, and PC tools. Support schematic capture to PCB layout and mechanical 3D modeling. Discuss placement requirements with the electrical and mechanical engineers. Develop and design all hardware schematic PCB layout and firmware in C. Design and develop various sensor and control boards using Eagle PCB schematic and capture software. Test and debug PCB and work with mechanical engineers in process design and wiring. Generate PCB design, Gerber files and source contract manufacturing houses to produce. Assemble the PCB, debug and modify the design of PCB board prototypes of the above product. Reduce PCB size and cost by moving more signal processing into software. Develop board PCB designs for various blocks and projects. Perform analog and digital circuit design, including PCB design and layout. Use tools such as Mental, Cadence, Concept, STL, and Allegro PCB. Design circuit and PCB for display board and control board. Create PCB for smaller device footprint and improve reliability. Create the final PCB layout for circuit using ORCAN. Prepare and maintain PCB technologies used in aerospace. Design schematic and PCB layout. Web power meter products PM21 single phase and PM31 three phase. Design order schematic. Review PCB layout. Product development is an high demand skill for embedded system engineer. Product development is the complete procedure of creating a product from concept until release of the final product. Product development has many stages, after which a product is released into the market. Identifying the need, creating the opportunity, conceptualizing a product, and providing a solution. All are different stages of product development. Here is how product development is used in embedded system engineer's job. Orchestrates significant hardware and software improvements that reduce product development by 4 weeks while optimizing configuration management and IO performance. Develop programs for automating aspects of product development, plan and execute multiple trips to Israel and Vancouver for training, knowledge, and transfer and interfacing with other product development teams involved in full product development cycle of the product from inception to completion. System design is an high demand skill for embedded system engineers. System design refers to the electronic structural component of a system. Here is how system design is used in embedded systems engineers' jobs. Specify microcontrollers and I/O connections for new embedded system designs. Design and implement software for embedded electronic system. Captured project requirements, performed system design, and manage projects and engineers. Develop system design specifications and software detailed design specification documents for the rail voice system using UML. Leverage strong mission application technical knowledge in system design and working with a developer concerned parties. Draft detailed design objectives and develop architectural and system design documents. Provide direction and approve system designs. Data acquisition is another high demand for embedded system engineer. Embedded systems development focus on data acquisition, close to control hardware and software design fabrication. Evaluate and implement various embedded systems for data acquisition and processing the measurement while drilling system design and procedure. All components of data system for real-time 2-camera video capture, convert data with 10-bit high-speed DAC and collect with NI data acquisition instrument USB 6212, mid-tunnel data acquisition system design and implement the wind-tunnel data monitoring and acquisition system. Maintain the firmware of Cairo Data's previous generation of 16-bit data acquisition board. USB is another high demand for embedded system engineer. Design device drivers for USB LED monitor system, UART, GPIO LED indicators, code many improvements to the WinCE public code and to the USB device drivers. Develop BSP with ARM assembly language for USB-led monitor system. Host driver with the default USB MSC driver of the Windows. Implement USB Ethernet emulation model drivers for QNX. Embed debugging using USB Beagle. Use Keel and IAR IDE to develop application, and DMA is used to stream audio to USB. Provide system expertise for few products, including those with Ethernet, USB, and LCD capabilities. Implement full speed USB communication between Windows PC and PC PIC 18 microcontroller. Develop quad-order audio autopilot flight features, write bootloader and PC utility for firmware upgrade over USB. Project USB I diagram to measure jitter, work to test and measure high speed USB transmission data jitter. Ethernet is an average demand skill for embedded system engineer. Integrate power meter with embedded TCP/IP stack. Provide Ethernet and Wi-Fi interfaces. Improve the performance and reliability of Ethernet board. Route network switch. Verilog project for design, simulation, and synthesis of an Ethernet network switch. Test and troubleshoot problems with PCIe cards, and network interface cards and Ethernet cards. Serve as the embedded networking device driver expert and develop an Ethernet device driver for devices and Solaris. Verify an Ethernet hardware layer using smart bits at ambience of 40 C, C10. Truth is there's an average demand for embedded system engineer. Develop an improved Bluetooth radio driver module. Work with TI Bluetooth low engineer SOC to develop a system firmware for smart sensor for ambient data network. Utilize DSP techniques to process sensing data and build a Bluetooth wireless interface for data transmission. Conduct research on ARM Cortex-M Bluetooth LE for add-on functions and system integration. Test and configure Bluetooth module for digital weight indicator. Lead the development of multiple embedded system projects for tools including motor control, battery management, and Bluetooth interaction. Design, test, and complete integration of Bluetooth communication system to allow wireless control of our flagship products, and add Bluetooth low energy connectivity to smart sensor to support IoT function to the ambient data network. Use Arduino program to write an algorithm that send the data via Bluetooth and store in EEPROM. Add Bluetooth wireless support for barcode scanning to our legacy products. Develop iOS and Android apps for debug and Bluetooth tool control. RTOS is an average demand for embedded system engineer. A real-time operating system RTOS refers to a plan tailored to serve real-time applications that process incoming data without buffer delays. Here is how RTOS is used in embedded system engineer's job. Yet the implementation of an RTOS and PID control system in future products. Design automated control models and write board support packages for VxWorks RTOS. Utilize C and ASM to program RTOS, GNU Linux-based embedded system. Design and implement RTOS, hardware and RTOS architecture for DRU M200 products. Exposed to Green Hills RTOS working for the firmware. Develop the real-time operating system RTOS and embedded software for different companies such as Win Driver System. Develop evaluation prototypes for a product using RTOS on a 32-bit AVR 32 Atmel processor. Complete work of RTOS and ISTOS on Arduino. Experience with 32-bit embedded RTOS environment. Design and develop a circuit board with GSM and Wi-Fi modules controlled with a 32-bit microcontroller running an RTOS. DSP is another average demand for embedded system engineer. Develop high-precision GPS-based timing solution and optimize the embedded DSP algorithm for new product lines. Evaluate and implement various embedded platforms, including MCU, FPGA, ARM, DSP, and PC 104 system. Participate in the team effort to design, test, and maintain DSP software for our camera system. Work on software DSP algorithm for interference cancellation on 802.11 wireless network protocol. Embedded system ran on BME-based boards with custom DSP boards. Be responsible for DSP-based circuit layout design. Program microprocessor DSP firmware. Work with 68HC118051 68000 TI DSP platform. Implement numerous multi-threaded TI, TMS320 DSP, MSP430, ARM 926, and PowerPC MPAC 860 POSIX based hard and soft real system. Test performance, static and dynamic specs of platform, process data in NI LabVIEW with DSP algorithm. Lead the project of developing firmware for brushless DC motor and TI DSP-C 2000 32-bit microcontroller. FPGA is another average demand for skill for embedded system engineer. FPGA stands for Field Programmer Gateway in general terms, and FPGA is a hardware circuit that a user can program to carry out one or more logical operations. They are programmable silicon chips surrounded by input and or output blocks that come together through programmable interconnected resources to become a digital circuit or system. It is compatible with both simple and complex functions that together act as a comprehensive multi-core processor. FPGAs are used in a wide spectrum of areas from equipments for imaging and video to circuitry for auto, computer, aerospace, military application, and electronics for specialized processing. If we implement MCBSP, IFS, and shared memory device drivers, which communications within a TI 320C55X and the FPGA. Project research for this project, design and implement software on a National Instruments SP963 to FPGA board, involved in hardware firmware interface definitions, hardware firmware testing, hardware board bring up, and FPGA function definition. Implement the system on the NI compact RIO using both the FPGA and the real-time sections. Develop FPGA cyclone UART in aviation for serial asynchronous communication or 232. Work on a complete FPGA redesign to support next generation bridge sensor. Program FPGAs in hardware reduction, redesign of trace. Derive many mathematical relationships formulas to verify various critical constants embedded in FPGA chip from practically obtained values. Enhance code for Atmel ARM chip interfacing with the FPGA to provide data rate with high spectral efficiency. Integrate testing with AVA Tech embedded FPGA specialist to increase design scalability to thousands of sensors. Design high performance hardware systems with FPGA, Xilinx, Cortex 7 using Verilog coding. Design, implement, and test an emulator for bridge proprietary infrared sensor using both Actel and Xilinx FPGA. Validate setup using Verilog programming in FPGA and or C with microcontroller or Uno. Analog is another average demand for embedded system engineer. An analog system refers to a system that uses continuously variable signals. Here is how analog is used in embedded system engineer's job. Interface analog video technology to hardware compression circuitry and translate output to TCP/IP packets. Collect input-output data of analog circuits to test for linearity. Design and implement an application, compress TV analog signals with MPEG-4 format and transmit the stream media signal by using Wi-Fi. Design software hardware interfaces to CPU peripherals, various sensors and other controls for analog front-end pulse processing electronics. Design circuit to isolate sensitive analog signals from noise and apply appropriate RC cutoff frequency filters. Develop an hardcore movement simulation program, reducing the development time of custom analog gadgets. Design based on digital signal processing techniques and very low noise analog circuitry. Embed microcontroller, microprocessor application in mixer analog and digital. Attach pyranometer as both serial and analog inputs. Device drivers is an average demand for system engineer, lead software engineer responsible for providing bootloader, OS, and devices as part of the AMP system. Design and implement real-time software for MS-DOS, interrupt-driven data communication and communication device drivers. Design the user hardware interfaces and they implement the user device driver and debug tools for unit integration and system test. Develop device drivers program for Unix and develop multi-threaded programs. Develop device drivers for accelerometer, MMA 8452Q. Develop x86 Windows kernel communication device driver. Windows is an average demand skill for embedded system engineer. Windows is a chain of operating system that controls a computer and is developed by Microsoft. Every version of Windows consists of GUI, graphical user interface, with a desktop that allows the user to open their files. Here is how Windows is used in embedded system engineer jobs. Develop, manage, and edit all documentation related to unique embedded enabling features found in Windows XP embedded. Serve as test manager for XP embedded remote boot for Windows XP embedded service package 1. Develop the required updates to the emergency boot disk for Windows ME. Use C and assembly in Windows C environment. Develop Windows-based alarm processing MFC GUI application. Design and development of Windows GUI and a benchmark data integrity application. Java is an average demand for embedded system engineer. Java is widely known programming language that was invented in 1995 and is owned by Oracle. It is a server-side language that was created to let apps developers write once and anywhere. It is easy and simple to learn and use, and is powerful, fast, and secure. This object-oriented programming language lets the code be reused that automatically lowers the development cost. Java is specially used for Android app, web and application servers, games, database connections, etc. This programming language is closely related to C++, making it easier for user to switch between the two. Here is how Java is used in embedded system engineer's job. Develop Java application for sophisticated prototype, future combat system program utilizing Java Spring and XML libraries for XML configuration editing. Develop Java applications for digital TV decoders, program using C, C++, C#, Java assembly, M4, and shell scripting languages. Implement these methods using GMP library and Java big integer class to handle large number calculation. Design dynamic web Java or device configuration and state display. Develop software in embedded Java and design hardware schematics in OrCAD. Implement a super pixel algorithm with simple linear iterative clustering, a select and k-means clustering in Java. Implement by multi-threaded programming for thread communication in both C and Java. Hardware is an average demand for embedded system engineer. Hardware is a physical part attached to computer or other similar devices. Components are the internal parts of the hardware, which include RAM, hard drivers, motherboard, and so on. External hardware devices, which include keyboard, mouse, printers, and so on, are known as peripherals. All of this together are called computer hardware. Here is how hardware is used in embedded system engineer's job. create hardware schematic design and layout using advanced microprocessors and FPGA, STL technology, precise video circuitry, and facilitate hardware software integration. Design microcontrollers based hardware and software systems for various medical and laboratory devices. Create and maintain detailed technical documentation on all developed hardware and software. Work with hardware and software engineers in integrating firmware control and communications. Develop microprocessor-based hardware and software for automotive and electric control system. Create and design prototypes and develop hardware for better performance. Participate in electronic design reviews and assist in hardware debugging. Participate in hardware design development and architectural discussion. Experience in developing the communication between the hardware devices and the software by the help of kernel, the operating system. Design hardware circuits for PIC controller with R&D team to interface DC, servo motors, power supply, and sensors. Develop and design the power management subsystems, power source monitoring, distribution, and battery management hardware and firmware. Or develop flash loader application to load hardware operating system RTOS into flash and run the code from flash. Design hardware and software for keyboard controller module, LCD display controller module, and serial communication module. Develop the H-bit hardware built-in test commands to test each and every interface of intercom. Modify existing firmware to correct existing errors. Adopt it for new hardware devices to improve performance. Lead hardware architect and embedded system engineers for the 3D LRR technical demonstration contract and TPSX advanced radar. Lead designer for software and hardware control solution for 5 new high power amplifiers used in satellite communication. Help diagnose hardware issues on previous generation chargers and provide hardware and software solution to address them. Design heating and fluid control hardware and sensor software experience, bringing up new product designs. Develop a variety of hardware interfaces for new Internet of Things IoT devices. Firmware is an average demand for embedded system engineer. Firmware is a software tangible electronic component which contains necessary instructions for the hardware to work with the operating system. Firmware is embedded software instructions that are used to tell an electronic device how to operate. Here is how firmware is used in embedded system engineer's job. Develop embedded system firmware in C and assembly language targeted to various microcontroller technologies, utilizing real-time operating system services. Demonstrate the ability to interpret and contribute to existing code written by other firmware engineers. Define firmware requirements and design corresponding algorithm for data routing. Design and implement embedded systems of firmware. Develop firmware for an impedance measurement system. Create a 3D printer by amalgamating various aspects of other designs as well as improving the open source firmware. Design, debug, and test firmware for companies all in one measurement while drilling MBW2. Design and develop firmware for autopilot of an unmanned aerial vehicle. C microchip development. Develop firmware in C, C++ to implement vehicle battery management system, ECU of hybrid and electrical vehicles. Perform simulations and testing of the firmware based on various conditions in real-time environment. Identify problems and design new working firmware in C using Eclipse-based IDE. Design and develop ROM sim and EEPROM emulated tool for firmware development and testing. Assist with firmware development of the Omni ID Power 400 active RFID tag. Perform using unit tests of firmware modules and field tests of integrated design. Provide consulting services and develop embedded firmware for CDC subsidiary. Work on firmware development, including writing sensor drivers, application code, optimize, enhance, and refactor firmware for high-speed optical scanners. Design includes initialization firmware for RX63 and internal timer and DMA modules. Implement device provisioning over the air firmware upgrades and sound processing. Implement all of daughter board firmware for battery-based product line. UART is another average demand skill for embedded system engineer. UART is known as the universal asynchronous receiver transmitter. Is a computer hardware device for asynchronous sequential communication where the data format and transmission speed are configurable. Transmission of data between 2 UARTs, require only two to create and implement algorithms which are instructions that enable the hardware to operate. Here is how UART is used in embedded system. Job interface GPS module with MSP for the TFC to our UART. Design and code a UART-based bridge module linking two microcontrollers used in the fixed access point devices. Provide test program script via Google Fastboot, ADB interface, and UART debugger Windows platform. Develop protocols for different interface communication. UART to Ethernet, UART to Bluetooth. Develop UART driver to communicate with a cellular modem. Develop assembly code for lattice FPGA to read temperature of different cores of the DUT and debug over UART. SOC is another average demand embedded system engineer. Embed interfacing of sensors with application processing. BLE SOC develop firmware for sections of log network communication system on chip, including intelligent peripherals. Manage SOC development by coordinating design efforts between digital and analog design teams. Coordinate SOC system, bring up memory map changes, processor boot, and low power mode operation. Develop DRAM initialization code for the new SOC. Coordinate with SOC engineers in the creation of test plans for validation and testing of new devices. Yeah, Wi-Fi is another average demand skill for the embedded system engineer. Investigate and document Wi-Fi performance issues on various products. Use oscilloscope logic and spectrum analysis to track RF signals through the Wi-Fi radio network. Create PSOC 3x5 project to support the Wi-Fi EVK board and design as part of the demo. Design solar powered Wi-Fi system to be used in low signal areas. Provide performance optimization, improving Wi-Fi throughput by 15%. Design the same user interface on the Dell Axim PD and synchronize the battery's condition through Wi-Fi. Customer requirements and another average demand for embedded system engineer. Develop innovative new products and features based on customer requirements. Provide expertise to determine system specification, input-output process, and working parameters to meet customer requirements and hardware software compatibility. Participate in peer reviews to help ensure documentation completeness in accordance with customer requirements. Participate in system specification reviews to ensure that the product met customer requirements. Perform in-full main functional and integration testing to ensure customer requirements are being met. Validate all embedded software functions according to functional specifications and customer requirements. Control system is another low demand skill for embedded system engineer. Work on embedded control systems includes components for sensors to power supplies, LEDs, LCDs, touch screens. Implement and test control systems of choice using inverted pendulum, HFLC COT system. Develop industrial and embedded control systems for a variety of applications, including metal alloy protection and forklifts. Analyze and design flight simulator, automatic flight control system using classical and digital control systems. Research technologies of attitude control systems for remote sensing satellites. Analyze and upgrade algorithm softwares for real-time distributed control systems. PC is a low demand skill for the embedded system engineer. Embedded PC 104 controller and custom board level associated system network design and implementation. Develop an embedded battery quality analyzer system and the related PC control software. Create several PC tools for device configuration, file parsing, and serial communication. Create an embedded wireless street lamp control system and its PC control software. Port PC-based soft DES to GBT and implement proprietary encryption folding technique. Develop a full J1939 protocol stack, bootloader, flash control, flash protocol, and PC-based flash tool for Maximac Tech standard products. Develop an engineering PC tool by C# optical intercoding. Project enhancement of multicolor, multi-line displays with both PC keyboard, computer interface. Define a .NET API for PC to embed device file transfer and communications. MCU is a low demand skill for system engineer. Involved in MCU and peripheral test, writing automated and manual test cases for embedded system. Detailed board level design of a MCU bit, 32-bit MCU, MPC, 5200B, second generation for an embedded system board. No debugging and diagnosing the MSP 430 MCU based hardware and firmware involved heavy usage of electronics as the scope. ASIC is a low demand skill for embedded system engineer. Work on start to successful encode, see reference model, provide test cases, test vectors, simulation supports for the ASIC engineers, assist tier 1 customers during ASIC designing, including circuit design, component selections, schematic review, and debug. Collaborate with the ASIC design team to ensure accurate operation of hardware subsystem IP block. Implement embedded software for initial ASIC boot up and power management for broadband cellular SoCs. Document and execute quality acceptance plan for an outsourced 2 million customer ASIC project. Develop firmware supporting the FC code SoC collaborated with ASIC engineers. RS2 is a low demand. Develop router algorithm for data routing from multiple meteorology sensor stations via RS232 serial port. API is a low demand for embedded system engineer. Use Apple's API reference to assist in the implementation of these classes. Develop RESTful API to communicate with backend server. Integrate a media client for end user application using Qt and tungsten video encoding decoding API to encode decode sensor images. Develop and maintain a common storage configuration monitoring API and an accompanying command line utility. Review technical requirements from OEM customers and implement APIs according to customer requirements. Use Spring Core annotations for dependency injection, Spring DA, and Spring MVC for REST APIs for microservices. LabVIEW is a low demand skill for embedded system engineer. Develop a vehicle simulator used for sending messages to the navigation device by using LabVIEW. Upgrade production line software to LabVIEW and integrate with MySQL database. Design GPIB controller GUI in LabVIEW. Develop fully automated calibration and verification for energy meters with LabVIEW. Develop a LabVIEW client for a diagnostics of the developed code and maintenance of operational code. Develop a LabVIEW application for controlling the system. GPS is a low demand skill for embedded system engineer. GPS stands for Global Positioning System, which is a navigation system comprising of satellites that help in determining the location, velocity, and synchronized time data for different modes of travel like air, sea, and land. Here is how GPS is used in embedded system engineer job. Contribute to the development of next generation GPS communication on microcontrollers. Develop and test a prototype for GPS-based ships, pollution prevention, and navigation system for ships for a client named Alphamar. Design of a small size embedded system to overlay aircraft position velocity information available from GPS onto the DVR video. Design test cases for GPS system, including environmental testing and use case test suite. Design and implement a modular based golf cart mounted embedded GPS system. Develop an in-depth understanding of radio communication protocol, GPS session, and over the air data logging methods. Test scripts is a low demand skill for embedded system engineer. Test scripts validate the quality of the software or app being used. Tested an effective test script has all the steps to be taken to use a software program as well as the ending result of each step. Here is how test scripts is used in embedded system engineer's job. Contribute to writing of test scripts and test description. Involve the tests, the designs test scripts in C to verify adapt code being written for embedded processor. Develop automated test scripts and architectures for application products. Develop automated test scripts using Computer QA run. Develop and execute manual and automated testing scripts using documented requirements and or design specification and record results. Create software requirements, test procedures, and automated test scripts in preparation for formal validation and regression. Unix is a low demand skill for embedded system engineer. Unix is a computer operating system that was first created in 1916 and has been constantly updated since then. The operating system refers to the set of programs that enable a machine to function. It is a multi-user, multitasking device that works on computers, laptops, and servers. Unix system also have a graphical user interface similar to Microsoft Windows that makes it simple to use. Here is how Unix is used in a system job. Design code and maintain Unix and DOS tools for DVT development testing. Configure the Unix systems services environment to deliver new technology. Develop and implement a process for migrating in case code from Unix workstation to an IBM iframe using TSO in MVS. Install, configure, deliver, and maintain a small customer client server LAN consisting of PCs running SCO, Unix, and Windows. Experience as the lead engineering and software support person for BMC control, VM for Unix and Windows at CNA Insurance. Utilize various file systems, including cluster file system, as well as backup technology and recovery techniques for Unix servers. BSP is a low demand skill for embedded system engineer. Develop the BSP for the unified platform, drastically reducing embedded development time for future embedded projects. Modify UC Linux kernel BSP configuration file to UC bootloader support. IDE is a low demand skill for embedded system engineer. Eclipse IDE with GWT plugin and GWT designer are used as a development tools. Update C# code written using Visual Studio 2000 and the Excel 2000 libraries to run with the current Visual Studio IDE. Embedded C for micro programming, controller programming on Code Warrior IDE. Develop iOS application using Xcode Core IDE. Develop software on the TIMSP 430 Ultra low power microprocessor using AR IDE. Source code technology C 8051F130. Keel New Vision 3v3.50 IDE. Tools VSS Signal SEC2 debugger and emulator. Assembly language is another low demand skill for embedded system engineer. Code in embedded C assembly language and Visual Basic C. Code in Motorola 68,000 assembly language. Job responsible, organize, maintain C assembly language source code in structured manner. Target processor microchip coded in assembly language design, the printed circuit board and packaging. Program and debug software for prototypes with various ICs in C and assembly languages. Perform the full development cycle for a bootloader for a PIC microprocessor written in real-time C and assembly language. Circuit boards is another low demand skill for an embedded system engineer. A circuit board refers to an electronic device used to offer mechanical support and connect components electrically using signal traces and conductive pathways. Here is how circuit boards is used in embedded system engineer's job. Design and build printed circuit boards to support neural recovery process that allow paralyzed patients to walk in. Evaluate circuit boards containing 5 unique power rails powered by a lithium-ion battery. Convert various legacy circuit boards to the current CAD tools. Design printed circuit boards using Altium Designer. Design printed circuit boards using Atmega microcontroller. Design and develop high-speed multi-layer circuit boards conforming to IPC standards using Altium Designer. PID is a low demand skill for embedded system engineer. Work on the PID controller that are programmable proportional integral differential controller that acts on the noise file moving mirror in the spectrometer. Design control algorithms for power supplies and write parametric PID control with Lab View 7.5. Emulators is another low demand skill for embedded system engineer. Use development kits, debugging tools, and ICE emulators. Analyze code using circuit emulators, protocol analysis, and other scopes. Use development kits, debugging tools, and ICE emulators. Use in-circuit emulators, PVCs, version manager, tracker, SPC, and SW engineering tools. Utilize benchtop equipment, including oscilloscope, logic analyzer, in-circuit emulators, and JTAG debuggers. Use Intel MDS in-circuit emulators, I2, ICE, and analyzers for the test and integration. TCP/IP is a low demand skill for embedded system engineer. TCP/IP also identified as transmission control protocol. Internet protocol is a computer networking system that allows computer to communicate and interact. Here is how TCP/IP is used in embedded system engineer's job. Implement TCP/IP stack providing HTTP, DHCP, DNS, SNTP, SMTP, SNMP, XL, and cloud services. Develop load blank driver through Modbus TCP/IP and integrate it into the system. Require TCP/IP socket-based special messaging protocol development for remote display and control of customized register-based devices and circuits. Implement TCP/IP communications to others network product. Develop TCP/IP enabled video user interface for a gamma radiation surveillance monitor. Re-engineer, design, and implant a client-server model over the TCP/IP protocols to NSTS network test controller. ORCAD is a low demand skill for embedded system engineer. Develop systems for use on various operating systems, replacing ORCAD schematic. Tool. Technical support is a low demand skill for embedded system engineer. Technical support or tech support are the services provided by any hardware or software company to users. They help in solving technical difficulties the customers face with their products or services. Moreover, the tech support employees maintain, manage, and repair the IT faults. They are also responsible for resolving network problems, installing and configuring hardware and software. Areas of technical support is used in embedded system engineer's job. Provide engineering and technical support during development of Neuron embedded system controller for maximum security. Industry. Provide technical support for robotic systems for sensor interface. Provide technical support for initial customer contract presentation. Provide technical support to clients around the world and fix it. Most of the there are some issues remotely. Award 2002 Motorola Brevo distinction for outstanding technical support on form. Provide in person and over the phone technical support to customers. Provide technical support to customers both during and after evaluation. Both JTAG is another low demand skill for embedded system engineer. Debug the issues based on the feedback of customers. QAs using JTAG debuggers, logic analysis, and oscilloscope. Evaluate various ARM and power PC JTAG emulators for possible purchase. Design user interface for onboard debugging without a JTAG station. Speeding up cycle by several orders of magnitude. Use Visual Studio CAD ULC compiler. WinCBS OpenGL requested for in-circuit emulated JTAG. Use JTAG scopes and logic analysis to do low-level signal debugging and design verification. Utilize JTAG technology with ITP, in-target probe, oscilloscope, logic analysis, and debug. Thank you.